In a digitized society, we encounter web-based services everywhere. Service providers are looking for new ways to detect attacks on their IT infrastructure and protect the highly sensitive data of billions of users. To support this effort, the research project Kiwi developed and tested new ways of machine learning for security-relevant information. In contrast to classical machine learning, federated learning distributes the model to the data across various devices or users, enabling decentralized training that enhances privacy. Researchers from the University of Applied Sciences Karlsruhe have investigated the application of data governance to federated learning. It consists of an iterative process with 3 phases. During the negotiation phase, participants discuss and agree upon the goals being pursued, as well as the training settings. Once an agreement has been reached, the federated learning training starts and the model is assessed. If the developed security measures don't obfuscate the participants' local models, additional information can be extracted. Finally, metadata regarding the 2 former phases is collected, as it provides valuable and non-intrusive information about what following steps need to be taken. Despite the security aspect of federated learning, the exchanged model information can still be subject to attacks. Researchers from the University of Applied Sciences Karlsruhe have also implemented a decentralized peer-to-peer federation to minimize the possibility of a third-party adversary. Applying encryption or obfuscation methods on the exchanged model information provides security. The pre-processing of the data is essential so that it can be used for training. For this, secure P2P communication is needed. These security enhancements could allow participants to successfully train a shared machine learning model and keep all sensitive information to themselves. Researchers from the Karlsruhe Institute of Technology have investigated the use of federated machine learning techniques to detect and mitigate DDoS attacks on network infrastructures. The AI detector identifies attack sources at a very early stage and reacts by filtering malicious traffic. Incoming traffic is highly aggregated in 2 dimensions, processing high traffic volumes at line speed and efficiently implementing countermeasures. The result, the services under attack can be used without restriction. As part of the Kiwi project, Adesso has employed federated learning techniques to train fraud detection models. This way, payment service providers are able to act swiftly when unauthorized transactions are made. In order to detect criminal activities, a transaction is passed to an AI model, which determines the probability of a scam. This can be used to halt the transaction. Federated learning significantly improves the model's ability to recognize credit card fraud, thereby preventing substantial financial damage. Identity misuse, such as hijacking another person's smartphone, is another problem for users and service providers alike. Researchers of the University of Applied Sciences Karlsruhe have created an AI detector that recognizes whether or not the actual user is interacting with the smartphone. This user data is encrypted directly on the device, which eliminates the possibility of misuse by the service provider. Federated learning helps to detect user behaviors in different types of applications and quickly deny access if an impersonator uses the phone. Similar attacks can also be launched on industrial networks. A single infected USB device, for example, can be enough to gain control over an entire factory or plant. As part of the Kiwi project, Sikuvera evaluates federal learning techniques to detect sabotaged OT networks at a very early stage by recognizing patterns of sensor and communication data. As soon as a detector recognizes the attack, the production plant can take action to keep damages small. If you want to learn more about the research, visit kiwi-project.org.